Hi everyone, welcome back to the channel. Hope you guys are doing great. Today we'll be starting off with our first lecture series, Let's Learn Quantum Computing from Scratch. And this is the first lecture. But before proceeding with our today's lecture, let's just try to understand how we will be doing these lecture series. So we won't directly jump to quantum computing. We will first look at the classical concepts of computing and information that will sort of enable us to understand the limitations of classical computing and the various factors that encourage us to move towards quantum computing. So you can say that these lecture series are kind of divided into two parts, where the first part focuses at the classical concepts, and then in the second part, we will then start with the quantum computing and information. And in our first lecture, we will be talking about bits. And what we have done with the first lecture is that we've basically divided it into three parts. Why three parts? Because we want to minimize the length of the video. And to understand what bits are, we will begin by looking at two of the most common examples that I think that we all have gone through in our math classes. And we will be talking about coins and dice in this first part of the lecture. And what we want to do in today's video is that we want to sort of perform an experiment with coins and dice. So basically, we want to flip the coin and roll the dice, and we want to look at the total number of possible outcomes that we're going to get. So this is what we'll be doing today. This is all what we'll be doing today. So this lecture is going to be pretty basic and very simple. You can say that it's a sort of revision, but a revision required to understand what we'll be doing in the next parts of the video. So without wasting your further time, let's get started and let's look at our first example. Let's look at coins. So before proceeding with the lecture, let me just hide the video. Yeah. So what are coins? So a coin is basically a flat object that has got two sides. And by flat, we mean that when you try to balance a coin on its edge, it won't balance. It'll fall to either of its two sides. And in order to distinguish between the two sides of the coin, what we do is that we label one side as head and the other side as tail. And now we want to say that each side of the coin, we want to call it as the state of the coin. So when you're flipping a single coin, you either get a head state or a tail state, right? So there are just two possible states that you're going to get when you're flipping a single coin. Now, what happens if instead of having a single coin, if we now have two coins? So let's say I have a green coin and my friend has a yellow coin, and we both want to flip our coins simultaneously, and we want to check that what possible outcomes do we get? How many possible combinations could we get, right? So the first possible combination or the possible state that you could get is that both of us get heads. So a head, this is the first state, head, right? The second state that you could get is head, tail. So head, tail is your second state. Third state that you could get is a tail head, right? Tail head. Or you could get both tails, right? So tail is the fourth state that you could get. So when you're flipping two coins, the total number of possible outcomes or the total number of possible states that two coins would have is 4, right? So head, tail, head, and tail. Now, what if we have 3 coins? So with 3 coins, you can see that when we're flipping 3 coins simultaneously, we could either get all heads, right? Or we could get a head, tail, head, or a head tail, or a head tail, or a tail head, or a tail head tail, and so on. So by looking at this table, you can list down all the possible combinations that you could get. So for the case of 3 coins, there are in total 1, 2, 3, 4, 5, 6, 7, 8. So there are total 8 possible states that you're having. So for 3 coins, you have a total of 8 possible states. And like this, you can then, keep on increasing the number of coins, and then you can like perform the experiment again and again. Now, what we want to look at is that what is the sequence with which this total number of possible states is increasing each time when we add a coin and then perform the flipping experiment. So you just saw that when you had a single coin, you just had 2 possible states. When you had 2 coins, you had 4 possible states. When you had 3 coins, you had 8 possible states. And for n number of coins, we say that we have 2 to the power n possible states. Now, what does this 2 represent here? This 2 is basically the sides that each coin has. So each coin has 2 sides, therefore sides equals 2. And n here, or these blue colored numbers that you see here as a superscript, this n represents the total number of coins that you currently have. So the way these total number of possible states is increasing is basically sides to the power n. So this is how you could generalize the expression for the sequence with which these possible outcomes is increasing. With this, we're done with our first example. Now let's move on to our second example. Let's look at dice now. So what is a die? A single die is basically a cube, as you can see on this image here on the left. That's a cube. What is a cube? A cube is a 3-dimensional object. And it's an object that has got 6 sides, or 6 faces, you can see. And each face or each side is labeled as 1, 2, 3, 4, 5, 6. So what happens is that when you're rolling the die, you randomly get the results, you randomly get the numbers, right? But whatever the numbers you're going to get is going to be out of this list of 6 numbers, right? And we call each side of the die, again, like we called each side of the coin as the state of the coin. In the same way, we are going to call each side of the die as the state of the die. So a single die has a total of 6 possible states, right? 1, 2, 3, 4, 5, 6. These are the total possible states that a single die has. Now, let's perform the same experiment with 2 dice. So what if we are throwing 2 dice simultaneously? Then what possible outcomes do we get? So let's suppose I have this green or a yellow colored die, and my friend has this blue die. And when we throw our dice simultaneously, the possible results that we could get is that maybe I get a 1, they get a 1 as well. I get a 1, they get a 2, 1, 3, 1, 4, 1, 5, 1, 6, or 2, 1, 2, 2, 2, 3, and so on. Like this, when you list down the total possibilities that you would get when you're throwing the dice simultaneously, these are the total possibilities or the possible states that you get. And what we've done here is that we've basically represented each state of the coin as an ordered pair. So if you, for instance, look at the first ordered pair, what does it tell you? That when we both were throwing the dice simultaneously, I got a 1 and my friend also got a 1, right? And like this, when you count all of these possible outcomes, when you count all of them, there are in total 36 possible states that you're getting for the case of 2 dice. And like this, again, you can keep on increasing the number of dice and then repeating the experiment. And then the total number of possible states would keep on increasing. And now we want to look at that what is the sequence with which these total number of possible states is increasing each time when you're adding a die and performing the experiment. So again, like we said for the case of a coin, it's the same concept that is being applied for the case of a die now. So you see that a single die, since it has got 6 sides, so therefore sides equals to 6 here, And these blue colored numbers that you see here, or as in the superscript, or this N here, basically represents the total number of die that you currently have. So the sequence with which these total number of possible states is increasing, if you want to write a general expression for that, that's basically size to the power N, right? Yeah, so that's it for today's lecture. That's it. This is all what we wanted to discuss in this video. This was a pretty simple video, pretty basic video. You might already have gone through this before. But so it was just a revision, but a revision required to understand this next part, which is coins versus dice, right? So in this next part, we want to compare coins and dice, and what sort of comparison we'll be doing. Well, that's something that you will watch in the next video. And with this, I shall now end this video. And thank you so much for watching and listening. If you have any questions related to this part, you can definitely write that down in the comment section below. If you have any feedback related to anything, like for instance, how to improve the content or anything, if you have any suggestions, you can also write them down in the comment section below. And we'll see you soon, probably tomorrow. Till then, take care of yourself and goodbye.